Alright, welcome back everybody. My name is Dustin, and in the last video we started looking into tools for our editor and we created the AbstractTool. In this video we're going to start creating the TileTool abstract class and hopefully getting into creating the CreateTileTool itself. We may not because there's a lot to go over, but that's okay. Let's get into it. So the first thing I'm going to want to do is to go into our editor and we're going to want to go add a new tool here, add new file, and we're just going to call this the TileTool.h. Don't know why this keeps doing that, but that's okay. Should automatically do that for us. Configure cache, but that's fine. So let's just add our pragma once. Pragma once, cool. And let's go to our CMake list, and it didn't add it in, and that's fine. We can just copy this one here, paste that in. We don't want it to be AbstractTool twice. I have a problem with hitting the save button all the time. Anyway, so TileTool.h. And while we're here in our tools, we might as well make another one and call that TileTool.cpp. Add new file, TileTool.cpp. Yeah, and we're going to want to include TileTool. Awesome. Make sure that we get it into our cache. And we just put this down a line, copy this. Awesome. So I'm just going to generate the cache again. Cool. All right, so let's go to our TileTool.h. And the first thing I'm going to do is include the abstract tool because it's going to be an abstract tool as well. And we're going to want to include entity. So we're going to want to say core, ECS, and entity.h. And let's go namespace, Scion editor. And we're going to have our class. It's going to be a tile tool. And it's going to inherit from our abstract tool. So public abstract tool. Cool. And we're going to have some private, protected, and public. Just getting those in there for now. Control KD. All right, so we have our abstract tool. Okay, so let's start with the private variables. We're going to need to know the size of the mouse rect for when we are drawing the chosen tile on the mouse cursor. The mouse rect will basically be based on the currently selected tile size. So that's the width and height of that tile. We want to draw that to the mouse rect. So we'll say that's just going to be a GLM. So GLM vec2, and we'll say m mouse rect. We're also going to want to have the ability to use a type of grid snap. So if we're using grid snap, we're going to want to keep track of the coordinates or the current grid coordinates. The grid coordinates are basically what cell we are currently in on the tile map. We don't necessarily need this. However, if we want to display to the screen later on what cell we are in when using the grid, we'll actually have access to that. So we'll say GLM vec2 m grid coords. And we also want to be able to disable and enable, or enable and disable the grid snap. So we're going to have a flag for that. So let's say bool mb, let's just say grid snap. Grid snap. Snap. Cool. Okay, so we're going to need two protected variables. We need a way to render the mouse tile to the screen, and currently we don't have an easy way to do that for a single sprite. Now we did in the beginning, but I kind of lost that all when we started creating the batch renderers. So right now we're just going to use one of our batch renderers. This is overkill, like for one sprite, but we will refactor this out later. The goal currently is just to get this working, and we'll start adding the stuff to draw one sprite later on. So right now we're just going to have, let's actually go up to the top and let's do a forward declaration. So we'll say namespace Scion rendering. Cool. And what did we call our sprite batch render? Is it just a sprite batch render? Let's go to our rendering and the include rendering core. And it looks like we just called it a rect batch renderer. Let's take a look here. Oh no, it's probably just regular batch renderer here. So yeah, it's just add sprite. It's just a batch renderer. No, we did call it a sprite batch renderer. So let's take that. So we'll copy this and go back into our tile tool. Paste. This is going to be a class. Whoops. Awesome. So we have that forward declaration now, and this is just going to be a shared pointer. So we can go std shared pointer of Scion rendering, and it's the sprite batch renderer. Cool. And that's just going to be MP batch renderer. We will be changing this later on, so we're not using a batch renderer because that is overkill for one sprite. Okay, so we're also going to need the concept of a tile. So what will a tile be? A tile is just going to be an entity that has various components. So we're going to have to create an idea of what a tile is. So in our case, we're just going to create a simple struct that can help us define what a tile is going to be for us. And we're going to do that in the editor utilities. So where is that? The editor utilities, let's go here. Editor utilities. So we already have this stuff here. Let's create a new struct, and it's going to just be called tile. We could call it editor tile, but I'm just going to call it tile. Okay. So now that we have our struct, what is a tile going to have? A tile is going to have a transform, a sprite. It could have a box collider or a circle component, a physics component with an object data, and it may also be animated. So we need to start adding these in. So we're going to need components for that. So instead of including them all, like right here, we can just create a file that will include all of those components for us. And we're also going to want to create another component here, and this is going to be a tile component. Because if you remember before, I said I want to separate game component or game objects from tiles. Like the tiles are going to be their own thing. So I'm going to create a new component here, add new file, and it's just going to be the tile component.h. Oh, I'm so silly. I'm putting things in the wrong places. So we shouldn't be here in the .cpp file, right? This is in our source. We actually don't want this here. So I need to actually make some changes. Sorry about that. We actually want to put this in our include and our components. This needs to be here. All components shouldn't be in both places. Let's see. All components. All components. So it looks like we already created all components before. Sorry about that, guys. I forgot about that. And I'm not going to want to have this in here because I'm going to be including this in a .h file. For the entity editor utilities here, it's going to be a .h file. So I'm not going to want to have this here anymore. So what we're going to do is we're going to take this out and we're going to fix all the issues that we have there. Okay, so we have that. And I'm going to want to go into our source and remove this or delete it. Delete all components, yes. Cool. And then let's take this tile component that I just created, .h, and drag it into here. Cool. And we got to make sure that everything is fixed in our CMake. Our CMake could be all out of whack now. Let's just close these because I don't know which ones they are. And we'll open up this CMake list. Okay, so where's our stuff here? Include. Right here, this doesn't exist anymore. Let's get rid of that. And let's copy this here and change it to our tile component. Cool. And let that regenerate. And I'll generate again because I've been messing around. We're going to have some errors because I'm making changes. Build system errors, that should be fine. All right, so it seems to be upset right now. Let's try to build and see where I went wrong. Oh, it actually built. Okay, so even though we removed that using namespace, it's still built. And that's fine. That's what I want. And we created that tile component. Let's go back to that here. So we have tile component. These are all in this. Yep, tile component. Not sure why it's doing that indenting, but that's fine. Let's actually open up another component as well. So our sprite component. I'm just going to want to grab this here. So I can come back to my tile component and paste that in. I'm going to need this to be pragma once. Pragma once. Cool. Let's go back to our all components. Is that there? It is. Good. So we have our namespace, and we're going to want to create our tile component. Now all my tile component is going to have, this is going to be a struct, sorry. All my tile component is going to have is the ID of the tile. That's really it. It's only so we can filter it by the component, because ENTT, we can use ENTT exclude, and if it's a tile component, we can exclude it from game objects and stuff like that, which is great. So I'm just going to want a uint32t, and that's just going to be the ID, and it's going to default as ENTT null. So in order to do that, I want to actually go and include ENTT. Where is my ENTT? ENTT dot HPP. I think that should work. All right, so error cannot find source file. Ignore that for now. So I actually, you know what? Let's just try. Yeah, so it won't even let me build right now. Probably because we have errors and we need to find those errors. So yeah, this is debugging, but it's something that is older. It's not actually configure cache. Let's see what our output says. Yeah, CMake list. Sign core CMake list, test one, add library. So it's still looking for that. I swear I got rid of that. Let's check our CMake file. Sign core, CMake, down here, include tile component. See what that said again? Source component is tile component. Yeah, I got rid of that. Oh, it added it there. Cool. Let's get rid of that. That should be fixed now. All right. So let's actually now try to build. Our build should be back. Yeah, it's back. And we'll just try to build and debug, but we removed that namespace that we're using in an H file. Now, we don't want to do that all the time. If you're going to do the using namespaces, do that in your CPP files. So see, we got all these errors here, and that's fine. We can go and fix that. Nope. Cool. So core utilities. Yeah. So they're here is because we are including all components. It's trying to see. So now we need to go Scion core ECS. And let's just copy this. And let's just go fix it everywhere where we made those. Error list. Where's this? Core utilities. And in core utilities, here we can say using namespace. Cool. That should fix that. Where else? It's all in core utilities. Render system.cpp. Same thing. Just come here. It's already using the namespace, so it should work. Okay, go back into the error list. Animation system. If we go up to the top, it's using it here, so it should work. Let's try to run it. Awesome. So we're building again. Let's close this down. And let's go back to our tile. So where was that? That was in, we have a lot of stuff open now. Let's actually just grab this and let's close all other tabs. Close other tabs. Cool. And we do want to have the KO. So we want this .cpp file. And we're going to want editor utilities. So we can actually close core for now. And then go back into our editor and grab the editor utilities. And get back to this struct tile. And up here, I can now include core, ECS, components, all components. Now, I forgot that we made that previously, so I started making it for this video, but that's fine. So now that we have all components, first thing I'm going to want here is to have the ID. Each tile is going to have an ID. So uint 32t, and that's going to be the ID. And it's going to default as ENTT no. Then we're going to want to have the different components. So the first component is going to be the transform. So Scion core ECS transform component. And that's just going to be the transform, and it's just going to be default. All these are just going to have default values. So we're going to have a sprite It's going to be a sprite component. Then we're going to have the animation component. So we can just say animation. Change this as well. Animation. Cool. Box collider. Box collider. Box collider. Then we're going to have the circle. We'll say circle collider. Circle collider. Circle collider. And we're going to have the physics component. So we'll just call this physics. 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 And then the object data or data. Object data. Change this. So now, in order to do that, we need to get the user data from Scion Physics. So we need to include physics user data. Go to the bottom here, and then we can say Scion Physics object data. Oops. Let's take that. Replace this line here. Object data. Cool. And we're also going to want to have some flags because not all tiles are going to have all these components. So when we're in the editor and we're picking the tile properties or tile attributes, we're going to want to have flags that we can check that'll allow us to set these values for that particular object. And if these flags are not set, it's not going to add these in. Okay. What do I care about the most? I want to see, is it a collider? So bool be collider. False. Not all are going to be colliders. Does it have an animation? False. Does it have physics? Also false. Cool. And we also want to put, so it's a collider, yes, but is it a circle? So be circle. False. Cool. All right. That's all we need right now for our tile. So we have our tile, the concept of the tile. We can go back to the tile tool. And now that we have our tile, we can actually have another shared pointer. So std shared pointer of the struct tile mp mouse tile. Now I'm calling it the mouse tile because this is the one that's going to follow the mouse around. And then we're going to use this tile, the values of this tile, when we place or create new tiles. Okay, so all the components and all the attributes that this tile has will be transferred to each new tile when we create them. So great, now that we have the concept of the tile and we have the mouse tile already, we're going to have some protected functions as well. So let's make a new protected. And let's have the functions. Okay, cool. One of the functions that we're going to create, I spoke about earlier, how I want to ensure that there is no tile in the location that I'm trying to place a new tile. This function will return the ID of the tile. If the ID is not equal to entt null, that means we have a tile there. Okay, so we want to go uint32 t check for tile. And this is just going to take in a position. Const glm vec2 reference position. That's it. We're also going to need a way to create the entities. This is basically just going to be a wrapper around the registry. Each tile is an entity. So whenever we call create entity, it will make a new entity based on that scene's registry. Okay. So we'll just say Scion core ECS entity, and it's just create entity. We're going to want another one that will create an entity based on the ID that's sent in. So uint 32 t, and it's just going to be the ID. Cool. We're also going to have two more protected functions. One of them would be to draw the mouse sprite. We can handle that here because the mouse sprite itself will be the same for all tools. It is what else we draw with the sprite that will change. Okay, so we can say void draw mouse sprite. Cool. And then we also have to override the examine mouse position from the abstract tool. So we'll do this here. So virtual void examine mouse position override. Awesome. Okay, so let's get into the public functions. So the public stuff, we're going to have obviously our constructor, and it's just going to be the TileTool. Destructor is going to be virtual. So virtual destructor, and it's just going to be default. All right, now we also don't want to be able to instantiate tile tools either, or we want them to be inherited by the CreateTileTool and the RectTileTool. So we will create two pure virtual functions, one that will be used to create the tile, and another one for drawing the tile, because they'll both be different. Because when we create the tile for the single CreateTileTool, it'll just create a single tile, where the RectFill will create all the tiles under the rect, and it'll also be drawing different things as well. Okay, so we want to create those two functions. So virtual void create, and that's going to be pure, and we're also going to have virtual void draw, which will also be pure. Awesome. We're going to want to be able to clear the mouse texture data. What this means is a way to clear the sprite component of the mouse tile. So we're just going to call void clear mouse texture data. Awesome. And since we're clearing the texture data, we're going to need a way to load the sprite texture data. So void load sprite texture. We'll just say texture. Well, we could say data. Yeah. Keep it consistent. And this is just going to take in the const std string reference texture name. Now this is just taking in the tile set. So the tile set will be the texture data that we're using. And inside of here, so we're going to have our texture data, but then we're also going to have our mouse rect for the width and height of that. And that's how we're going to set our UV values. Okay. And let's also create a simple getter that will get the sprite texture for us if we need it. So const std string reference get sprite texture. Awesome. This could be const here as well. We can put these together. All right. We're also going to need a way to set the tile components. So we're going to have some setters for this. We want to be able to set these all from IamGUI. So whenever you're creating a tiles, we're going to have a panel that will allow us to choose what values each tile has. Like what size is the box collider? What sprite layer are we doing? The scale, animations, stuff like that. So we're going to add those in now. These are just going to be void set box collider. And we're going to say int width, int height. Are these, wait, let's take a look at our box collider. Are these even int? Just to make sure. So go here to include core ECS components. Check out our box collider. And they are ints. Cool. Then we have our offset, colliding. Awesome. We don't need to set this. That's set in game. All right. Back here with height. And then we're also going to have a GLM back to offset. Now, I'm pretty sure this could be const reference. I'm not sure with GLM. Yeah, cool. So we have our set box collider. Then we're going to want to set sprite layer. So, and this layer is just an int layer set sprite layer. Then we're going to want to be able to set the scale. That's going to be a GLM vec2 scale. Set scale. Then we're going to want to set animation. So let's just write this in. Set animation. So what does the animation have? It has a number of frames. So num frames. It has the frame rate. It's going to have, is it vertical scrolling or not? Be vertical. Then is it looped? So will be looped. And then it's going to be the frame offset. So int frame offset. So the frame offset, if you don't remember, is the offset from where in the sprite map or sprite sheet where's the offset from? So say you have like 2 different rows of sprites and you don't want to use the first row. Well, you have an offset to push you over to the next row. Then we're going to want to be able to set the sprite UVs. So void set sprite UVs. Now this is just going to take in the int start x and start y. Now this under the hood will handle the actual setting of the UVs. Cool. And we're going to have our physics props. So we're going to have to create tile properties. So that's going to be a to do set physics props. And we're also going to want to set the sprite rect. So void set sprite rect. That's going to be const glm vect2, and that's just going to be the mouse rect. No, it's going to be the mouse rect, but we're going to just say sprite rect here. Makes more sense. We're also going to want to be able to set our collider flags. So void set collider. That's going to be bool b collider, animation, physics, and circle. We'll have physics here. We'll do circle under the collider. Physics set physics set animation set circle. B circle, B animation. Awesome. Great. So we're also going to want to ensure that the mouse sprite is valid before attempting to place tiles or draw the mouse sprite. So that's just going to be a simple const bool sprite valid. Const. Cool. And last but not least, we want to be able to disable and enable grid snap. And these can just be inline void enable grid snap. That's just going to be mb grid snap is equal to true, false for disable. All right, KD. We got a lot going on here. That shouldn't be red still. GLM vec2. Anyway, we have a lot going on here. We should be including GLM there. Yeah, it's fine. Let's just copy this. Oh, it's because it's just a vec. You guys probably caught that. Okay, so we got a lot here, and we're going to want to create them all. So let's just highlight everything here. Do we put our namespace? We might as well put our namespace so it knows. So namespace Scion editor. Cool. We have that there. And let's just highlight everything. Except for that. And we'll fix that as well. Control period. Create declaration definition. Awesome. Created them all. This should have a capital S. Wonderful, wonderful, wonderful. Let's go into our TileTool.cpp. Now there's a lot there. And that's all right. Okay, so where's our examine mouse position? Right here. Good. Create and draw. I don't know why it's creating these, but I don't want them. Those don't want it. We don't want those there. Put a little bit of space between these. And we'll add more as we get down there. So the examine mouse position, I'm going to actually put this at the top, or yeah, right here. Actually, no, we'll leave it there. That's fine. So check for tile. The check for tile, we're going to want to loop through all of the tiles and check to see if there's a sprite there already in that location at that layer. So we actually have some includes that we're going to need. So here, we're going to want to say include. Let's get the logger. Logger And we're going to need to include our editor utilities. Editor, where is that? Editor utilities. That will give us all the components that we need. And we're going to want the main registry. So include core ECS main registry. Cool. And we're going to need the camera, the batch renderer. So include rendering core batch renderer camera 2D. We're also going to need the asset manager. We can do that up here. So include core resources asset manager. And I think that's good for now. Let's use our namespace. So we'll go using namespace Scion core ECS. All right. So for the check for tile, the first thing I'm going to want to do is check to see if the registry is valid. If the registry is not valid, we're just going to return entt null. So if not mp registry, we should have access to the registry. We do. And it's going to be return entt null. Awesome. So now let's get the tile view. So what I want is I want to get a view of all entities that have a tile component and a transform component. So it'll be if, not even if, so auto, and we'll just say tile view is equal to mp registry get registry dot view tile component. So I must not have included tile component in all components. Editor utility should have all components. All components should have tile component, and it does not. So let's include that. Awesome. Let's go back to TileTool.cpp. So we're going to want the tile component and the transform component. Great. And from here, we're going to want to loop through and do some checking. Okay. So we go for, and it's just going to be auto entity in tile view. So for each entity in tile view, we're going to want to loop through and check their position. Okay. So we go Scion core ECS. We don't need to do that. We can just go entity. Whoops. And we're going to say tile. And what we're going to do here is send in the MP registry, and we're also going to send in, as you can see, one of our constructors for entity could take another entity. So we take this here, boom. So now that we have our entity, let's get the transform and the sprite. Why do I want the sprite? Because I need to know the layer, and I need to know the sprite width and sprite height. Okay, we can say const auto reference transform is equal to tile dot get component, and that's going to be our transform component. Transform component. Cool. And then let's do this one as well, and this is going to be our sprite. Sprite. Now we want to check the position. Okay, we're sending in a position, so I want to go if position dot x is greater and equal to transform dot position dot x, and position dot x is less than transform dot position dot x plus the sprite width times the scale. So transform dot scale dot x. That's 1. Now we can put this in brackets, but we don't have to because of bed mass. So we can say and, whoops. So we can copy this line down. Let's make this a bit smaller so it all fits on one. Copy this line down, and then I'm going to want to put this back up. And do the same thing for y. Y. This will be height. and Y. Cool. And last but not least, I'm going to want to check the layer. So if MP mouse tile sprite layer is equal to sprite.layer. If so, I'm going to want to return static cast uint 32t of the entity. Else just return. If we come outside of the for loop, we just want to return entt null. Now, we don't want to return 0 because 0 is an valid entity ID. So we don't want to do that. We want to return entt null. Okay, cool. And that's it for our check tile. All right. And the create entity is pretty straightforward. We're just going to want to go scion assert MP registry. And then just the registry must be valid to create an entity. Now, if the registry is not valid, we will crash here. That's why we do debugging, because we want to make sure that the registry is valid, because we need a registry to create one of our entities, okay? And in here, we can just return an entity, and it's going to take in the registry, MP registry. And then just because we have different constructors, we're going to do our basic constructor here with the name and group. We don't have to pass anything else in. It'll know, it should know which one to do, but we'll pass it in anyway. Cool. And we can copy this here and just paste this and then change this. And we're going to want to say static cast entt entity, and it's going to take in the ID. Cool. So we're just sending back, this one is going to be a bare bones entity, and this one's going to be another entity based on an ID. We're going to need this one later on. Cool. Now, the draw mouse sprite. Drawing the mouse sprite is exactly that. We have done this before with our batch renderer, so we're just going to add a sprite to the batch, and we'll change this later on to not use the batch renderer. But for now, let's just do that as we've always done. So MP batch renderer begin. So we started that, and we're going to want to get the sprite and the transform from the mouse tile. So we're going to go const auto reference sprite MP mouse tile sprite. That should be equals, sorry. Now we don't have to do this. I just find using just sprite by itself is cleaner than MP mouse tile sprite. And we're going to want to do the same thing for the transform. Cool. If you remember the add sprite function, we need the position, the UV values, and the texture ID. Okay. So we can say glm vec4, and that's going to be position. And it's going to take transform.position.x.y. That should have a comma. Then we're going to need the sprite width times transform scale. So sprite.width times transform.scale.x, and then y, and height. Cool. We can make this bigger again. And then we want to do our UVs, and that's just glm vec4 UVs sprite dot UVs dot U dot V dot UV width and UV height. Cool. Now we're going to want to get the texture from the main registry. So we go const auto reference p texture is equal to, doesn't even need to be a reference here, just const auto, because we're sending back a shared pointer. So main registry dot get asset manager dot get texture, and then this is sprite dot texture name, and then if p texture, then we want to add our sprite. That takes in the position, takes in the UVs, it takes in the ID. So for that we need p texture get ID. Now it takes in the layer, and for now we're just gonna have like a layer of 10, or the highest layer. Let's just put up here. Let's say const expr int mouse layer, mouse sprite layer. Yeah, mouse sprite layer, and that's going to be 10 for now. I doubt we'll use more than 10 layers, and but if we do, we can just change it. Cool. And let's go back down here. Mouse sprite layer. And we're gonna not worry about the color and stuff right now. Actually, yeah, we will. So let's do our mat 4, and we're not gonna have any rotations right now. So glm mat 4 1.f. So we'll just send in the identity matrix and sprite.color to finish it off. Cool. And then right inside of here, right away, we're just gonna do our batch.end, np batch render.end, and then the render. Great. All right, in this case, examine mouse position will need to update the transform of the mouse tile. If we are using grid snap, we're just going to have to adjust it to the grid. If not, we'll set the transform position based on the mouse position itself. This will be based on the top left corner of the tile. We could also center it on the mouse cursor if desired. We can add a flag in to allow the user to place it off center or on the top left, off the center or the top left corner. So let's do that now. The first thing I'm going to do is actually get the mouse position. So const, and it's the mouse world position, auto reference, and it's just going to be mouse world pause, and that's going to be equal to get mouse world chords. Okay, then I also want to get the transform of the mouse tile, and this is going to be a reference because I'm going to want to be able to change this, and that's going to be mp mouse tile transform. Now, we're also going to want to get the camera scale. However, if the camera does not exist, we can just leave, actually, and we can just do that at the top. So if not mp camera return. There's no need to keep examining if we don't even have a camera, because the camera we need for scaling and different things of that nature. Okay, so after we get here, we can actually get the camera scale. So we can go const float camera scale, and that's going to be equal to mp camera get scale. All right, so now we want to check to see, are we using the grid snap? So we want to go if mb grid snap, and we'll do this in a minute. First we'll do the else. So if we're not doing grid snap, it's pretty straightforward. We're just going to want to set the transform position of our mouse tile. So this transform position of the mouse tile based on the mouse position, mouse world position. We could have a flag in there to adjust. So something like, we can say transform dot position is equal to mouse world pause. And then first we can say, like, have a ternary operator, like b is, we'll just put this here as well, just for fun. So we say bool b is offset, and we'll just have that as true for now. And we'll be able to set this, but this is just the idea. So we'll just say here is b is equal to, are we offset? No, so b is offset, so b is offset, and if so, we want to do mouse pause minus mouse mouse rect times 0.5, and then else It's just the mouse world pause. World pause. Okay, so if the position, if we're offset, we're going to want to offset it on half the size of the mouse rect from the world pause position. So it'll put the center of the tile on the mouse pointer. Okay, else we're going to set it to the corner, top left corner of the mouse world. That will be our position. Cool. All right, so now for the grid snap. The grid snap, we're going to have to do a few things. First thing I'm going to want to do is create a new GLM vec2, and that's just going to be mouse grid. We can just go 0.f. Cool. So I want to see if the mouse position.x is greater than 0.f. So if mouse world pause dot x is greater or equal to 0.f, then I'm going to want to set this grid position that we just created, mouse grid dot x is equal to static cast int, and I'm going to want to divide the mouse world position by the mouse rect, okay, based on the camera scale. So we want to go mouse world pause dot x divided by, this is going to be in another bracket here, m mouse rect dot x times transform dot scale dot x, and this is all going to be multiplied, these two are going to be multiplied by the camera scale times camera scale. Cool. All right, and we're going to want to do the same check for y. So if y is greater than 0.f, y mouse world y divided by mouse rect y scale y. Cool. Now that I have those, I'm going to want to set the transform position dot x. So now transform dot position dot x is equal to std floor, and I want to do the mouse grid dot x divided by the camera scale and multiply this by the mouse mouse rect dot x times the transform. And we're going to want to do the same for y. Whoops. Cool. And then now after that, we can actually set our grid coordinates, okay? And we're going to want to set them to the mouse grid divided by the camera scale. That will give us the coordinates. So m grid coords dot x is equal to mouse grid dot x divided by camera scale. And then we can do the same for y. All right. Last but not least, we want to set the world position. The world position now is going to be based on the newly set transform position. This should add that snapping ability that we want. So we want to set mouse world coords, and that's just going to be transform dot position. Awesome. And that's all we need for that. Okay, so we have our grid snap. We may need to adjust this later on. It's working for me the way that I like it, so that's fine. So we have our transform. If we're not using grid, we have this. Okay, and let's take a little look at our constructor. The first thing I'm going to want to do in our constructor here is I want to initialize the abstract tool, and then I'm going to want to do the batch render, mp batch render, std make shared. That's going to be Scion rendering sprite batch render. Cool. Then our mouse tile, mp mouse tile, std make shared tile our mouse rect. Actually, did we declare our mouse rect first? Yeah, so we want to put this stuff above. This stuff all needs to be above these things down here, okay? So here, we want to leave those two there, put these here. Cool. Grid snap, we'll just say true for now. Grid chords, 0.f. And the mouse rect is, I actually want to default this to 16. So 16 by 16. Let's get rid of these semicolons. KD. Get rid of that space. Awesome. All right. So everything should be initialized now. So the clear texture data is going to be straightforward. Did I miss any functions yet along the way? I don't think so. Good. So the clear texture data, all we're going to do here is go MP mouse tile at sprite is just equal to a new sprite component. That should clear everything for us. All right. And yeah, we got a lot of stuff here. Where's the update function? Did I skip that? So TileTool. Oh, looks like I didn't override the update function. So I must have missed that. So that's one of the first things we're going to want to do. So we're going to want to go virtual void, and then we're going to say update and canvas reference canvas, and that's going to be an override. And we can create this. All right. So since we're overriding this, I'm going to want to call the AbstractTool update function and send in the canvas. And then I'm going to want to call the examine mouse position. Cool. Okay, so this video is actually getting quite long, longer than I wanted it to be. So we're getting pretty close to actually having a functioning tile tool as well. So what I would like you to do as a challenge is fill in the rest of this. So load sprite texture data. What are we doing here? So I just want to take the sprite and I want to load the data. Actually, instead of that, we'll just do this fast. Why don't you pause the video right now and see if you can fill this stuff in yourself. We're just setting the components on the mouse tile, okay? Give it a shot, see what you can do, pause the video, and if you get stuck, I'll walk you through it. However, I'm gonna go through this quickly because you should be able to figure this one out. All right, pause the video now and take a crack at it. All right, cool. So now let's just quickly go over this. I'm gonna wanna go mouse tile sprite is equal to a sprite component. And here we can use the aggregate initialization and say width is equal to m mouse rect dot x. Height is dot y. We're going to want our color. For now, we'll just set the color because we're just loading the texture. The color is just going to be Cyan rendering color 255, 255, 255, 255. So just white. Cool. Start X. That's just going to be 0 for now. And start Y. Start X, start Y. The layer will also be 0 for now. And then the texture name. Whoops. Cool. Now that we set those, we're going to want to get the actual texture and generate the UVs. Okay, so auto p texture is equal to main registry get asset manager dot get texture, and that's going to be the texture name. Then we're going to want to assert Scion, assert that P texture exists. Texture must exist. And if it exists, we want to say MP mouse tile sprite generate UVs. And we're going to send in P texture get width and P texture get height. Awesome. Get sprite textures, pretty straightforward. So just check to see if we have a mouse tile. So if not MP mouse tile, return else we're going to say MP mouse tile sprite texture name, and we're going to want to return this. Cool. Set the box collider, so the same idea, and we're just going to fly through this. So we're going to have the box collider, and we're just going to set everything accordingly. We're going to set all these ones fast, so follow along and you should be able to do this. Cool. All right, and for the sprite valid, we're just going to want to set not MP mouse tile sprite texture name empty. So if the sprite has no texture, it's automatically invalid. Now we could do another check to see if it's also in the asset manager, but this should be good for us for now. All right, so hopefully you're able to do all that. And if not, just slowly go over it. You should be able to figure it out. It's pretty straightforward. We're just setting the components based on the values of the mouse rect and the sprite data coming in, okay? That's it for this video. It already went on long enough. In the next video, we're actually going to start creating those tiles. We're going to get into the CreateTileTool and actually be creating tiles in our tile map. All right, so that's it. If you have any questions, please leave a comment below or whatever you need to do. Also, please like and subscribe if you haven't done so already. That's it. Take it easy.